Okay, so we are going to, as soon as I get rid of that dock, we're going to take a look at finding the slope of a line given a graph. But before we do that, we're going to look at a graph with some points on it, and we are going to determine what makes a lattice point and what makes a point not a lattice point. Now, as you can see here, the points that I have in red, and we'll circle them, and I'll use red to circle them: A, E, and B. You can see that they're right on a place here where the grid lines cross. They're kind of like in the corner of a box, I guess you could think of it that way. Okay, those are my lattice points. They're called lattice points because the coordinate system sort of looks like lattice work that you would see around the porch, and that's what we call these points then that hit right where the grid lines connect. They're called lattice points. All right. So if you want to look at look at them as ordered pairs, and why is this not working here? There it is. All right. So my ordered pairs for those 3 points that I have circled, if you look at them, all of the numbers are integers: -5, 6. Those are both integers. There's no decimal. 7, -8. -9, -9. Lattice points never have decimals or fractions. They always have integers in their ordered pairs. Now, if you look at the non-lattice points, those are the green ones. The ordered pairs for the non-lattice points do have decimals, and I can circle them on here. That's C, D, and F. All right. And if you notice, when you graph a non-lattice point, for instance C, I'm going over -1/2, and I'm going up 1. And you see, I don't end up in the corner of a box. I might end up right on a grid line, but it's not where the grid lines cross. Same thing with F. If you see F, it's floating around right in the middle of one of these squares. It's not in the corner, so it's not a lattice point. Same thing with D. It's kind of floating around off to the side here in this box. So to be a lattice point, the ordered pairs have to be integers, and the point when you graph it is going to be in the corner of one of the boxes. All right, and that's important to know that because when we attempt to graph or find some points to get the slope of the line, we need to pick lattice points whenever we're doing that. All right, so let's go ahead and take a look at a couple examples here of finding slope. To get the slope of a line, we have to remember that the slope is the steepness of a line, and we think about slope as being the rise over the run. Okay, the letter M stands for slope in math, so this tells me slope is equal to rise over run. So let's see here. Let's find the rise and the run of this particular graph. I'm going to start at this point. I can start at either of the 2 points, but I'm going to start down here, and I'm going to go up until I'm even with my other point, and I'm going to count how many I go up. 1, 2, 3. I go up, and since it's in the positive direction, it's up 3, and I'm going to put a 3 right there, and then I'm going to run second. Whoops, let's see. I'm going to run over this way and hit my point, and let's see how many spaces I went. I went 1, 2, 3, 4, 5, 6 in the negative direction. So I'm going to put -6 right there for my run. So when I go to find write my slope, I'm going to write M equals, my rise was 3, and my run was -6. Now I always want to reduce my fractions, so I'm going to make this -1/2 as my answer. All right. Let's go back. Let's say we didn't want to do it that way. Let's say I wanted to start it with this point right here instead. You say, well, why can't we start with that one? Well, you can. This time we do our rise, but we're going down, so it's going to be -3. And then we're going to run over. And And the run's going to be 6, but it's positive 6 this time because I'm going in the positive direction. If you look at the number line up here, as we go this way to the right, it's positive numbers. So our slope is -3 over 6, and that's going to reduce again to -1/2. So no matter what way you do this, you're going to get -1/2 for the slope. Alright, let's look at another line here. Right here, we want to find the rise over the run, so let's rise. Well, here I'm rising 3, and I'm running 1, 2, 3, 4. So my slope is, why does that not right? 3 over 4. Let me show you that you can do this another way too. I could have started at this point and I could have went down. That's fine. My rise would be a negative amount though then, and I could run in a negative direction, -4, and when I go to write my slope, I'm going to have a negative rise and a negative run, but a negative over a negative is a positive. So it doesn't matter how you decide to do it, which point you start at, your slope for this line is going to be positive 3 over 4. Alright, let's see here. Let's go down. Some of the words we talked about yesterday in class, I'm going to clean this up here real quick. There we go. Or some of the definitions and different terms we used yesterday. I wanted to go over those here real quick as a review. So, let's see. First off, what's the definition of the word slope? Whoops. Well, slope is the steepness of a line. It tells you how steep it is. We talked about how slope is something you think of when you're thinking about like a hill or a roof or maybe even a road. Anything that has some kind of steepness to it, some kind of grade. So the slope is the steepness of a line. We use the letter M for slope in mathematical formulas, and we commonly think of slope as rise over run. So those are some things that we need to know here. Alright, if we looked at these different lines, they each have a different type of slope. There are 4 different types of slopes. We have zero slope, which is a flat line, horizontal, right here. We have positive slope, which as you go from left to right, the key is left to right, it's uphill. Negative slope is going downhill. Okay, makes sense, down, negative. And undefined slope is straight up and down. So those are things that we talked about and that we need to know as well. Let's see, what else do we have here? How many points do we need to find the slope of a line? And it would be nice if this would work. 2. We need 2 points. How many points are actually on the line? Well, there are a lot more than 2. There are infinitely many points on a line. We could count them until we were 100 years old and we still wouldn't be able to count them all. What is a line? Well, it's a picture of all of the solutions to a linear equation. And what are solutions? They are ordered pairs. Okay, so those are all things that we need to know about a line. Or a line and slope. To get slope, we need 2 points. There are actually infinitely many points on a line. The line itself is a picture of all of the solutions to a linear equation, and the solutions are ordered pairs. Alright, let's find some more slopes here. Let's see, this first one. Let's rise and run. My rise is 1. My run is 6. They're both in the positive direction. So my rise over run is 1 over 6. For this next one here, I'm going to start at this point. This time if I just look at it, look, it's going downhill. It should be negative. This other one's uphill. It was positive. Let's see here. My rise, down 2. My run, that is positive 9. I went over towards the right, which is positive. So my slope is negative 2 over 9. You see that? Negative 2 over 9, just like we'd expect it to be. Let's see. For this one, number 3, I'm going to start here and go up. We see the slope's negative 2 because I tapped it. Let's go up. Our rise is going to be 5. Or I'm sorry, 6. Okay. Our run is negative 3. Well, you might say, well, why did it pop up as negative 2 over here for the slope? Well, let's think about that. The slope is 6 for the rise, negative 3 for the run. If you reduce that, or if you divide it, you get your answer, which is negative 2. Okay, so that's how you'd want to write your answer right there. And our last one here, let's see, we have a point here. We'll go down. We went down negative 1. Let's go over to our other point. Looks like we went over, I'm going to write it up here because I'm running out of room, 9. So my slope is negative 1 over 9, just like that. So a couple things we need to remember to find the slope of a line is that it is rise over run. You always want to reduce your fractions when you get an answer there, and if you do that, you should be good to go. It's also important that when you look at the line initially, you just decide whether or not it's going to be a positive or a negative slope, depending on whether it's uphill or downhill. It may also be 0 and undefined also, as well. All right, let's see. We're going to skip those two. All right, last thing we're going to do here is take a look at lines that don't have points already drawn on it like the other ones did. And we want to find some lattice points that we were talking about earlier. So what I'm looking for is where this blue line crosses a corner of a box. So there's a point right there at negative 4, positive 1. That would be a lattice point. Up here in the corner, that would be another lattice point. That would be enough for us to find a slope. We could do a rise, which would be 2, and a run, which would be, 9. So we could say the slope was 2 over 9, just like that. Okay? Let's look at this one. This should be another positive slope. Let's see, here's a lattice point right there where the line crosses the corner of a box. You have to be careful with this. There's another one right there. We could get this slope. Looks like our rise is up 1 and over, what would that be? We went over 3 and then 4 more, that'd be 7. So our slope would be 1 over 7. Now, the last two lines, we only had 2 lattice points. This particular line, if you look, there's a lattice point right there where the line hits the corner of a box. Let's see, right there is a lattice point. Do we have any other ones? We actually have 3 lattice points. Do you see that? When this is the case, that's okay. We only need 2 though, so I'm just going to get my slope using 2 of these points. Let's see, we'll use red. And let's just use this point right here and this point right here to get our slope. So my rise is up 2. My run is 5. So my slope should be 2 over 5. Now, some of you might be saying, well, I don't want to do it that way. I want to start at this point right here, and I want to go the whole way to this point over here and get the slope. Is that going to do something different? Well, let's see. We have to do the rise first, which is negative in this case. So that's down 1, 2, 3, 4. So negative 4. And my run is the whole way across this beast in the negative direction. Negative 10. So let's see. Let's write our slope. Rise was negative 4. Run was negative 10. And, whoops, what happened there? If you think about this, a negative divided by a negative is a positive, and 4 and 10 can both be divided by 2, so we can reduce that fraction. 4 divided by 2 is 2. 10 divided by 2 is 5. And so you see we get the same slope regardless of which 2 points we use to find the slope. Okay, and that's something that's pretty neat about finding the slope of a line. So I think we'll stop right there for today.